Okay. So Davik and Arush, how does the classroom look now? Better? I put a lot of effort to paint it.
Oh, you think so?
Yep. And by the end of this week, the flooring will also change. So alright, so that was just to tempt you guys to be in the classroom as long as it is not way too far, like for Tanvi to take a flight from California to be here, or for somebody to come from Houston, or for Dave to, Dave and Vishal to take flight again. Alright, so what are we going to learn today? In the previous class we talked about focus and dimetrics, and that was a very unique concept that we talked about with respect to parabola. And right now we are in the unit which is talking about conic sections. So if you talk about conic sections, we kind of deliberated on what is a conic section, how circle, ellipse, parabola and hyperbola is a subset of conic section. That part everybody is clear about, I believe. Yeah? Vishal, Samriddhi, Dave, Davik, everybody? Okay, Tanvi. Alright. So now in today's class we are going to focus on another child of conic section called ellipse. And we briefly just touched upon it, but we did not go into detail. Or who is Kanao?
It's me, Akshaya.
Akshaya. Hey Akshaya.
Yeah.
Alright. So today we are going to talk about ellipse and its related properties and how do we deal with problems relating to ellipse. So everybody here, Arush, leave that. So now when we talk about ellipse and compare that to a circle, I know it doesn't look like a circle, but just believe me, that is a circle. Can everybody see the board okay? Can you guys see what I'm drawing on the board?
Yeah.
Okay. So this is ellipse, this is circle. Let's get the visual of it right. What is the difference that you see between these two? Yeah.
The ellipse has two radius, like one horizontal radius and one vertical radius.
Okay. Horizontal and vertical radius. Okay. Any other difference? And again, when you are giving examples, always assume that your teacher is not an intelligent person. You have to explain me like a child. Any other definition, understanding? Yes, Vishal.
For the circle, every point is like the same distance away from the center, but for the other one, it's not the same distance from the center.
Right. Okay. So let me not deal with puzzles for long enough. Now what we are doing is we are breaking these two shapes into 4 pieces. Meaning I am using this x and y axis for splitting this into 4 equal pieces. So this is my y axis, this is my x axis. Similarly, this is my x axis, this is my y axis. Now what you see is, you are seeing from, if this is my origin, there is one distance here, there is one distance here, one distance here, one distance here. Here in this case also you have 4, you are seeing 4 pieces of it, or 4 sides, that is kind of splitting this into 4 pieces. Now the difference between these two in the simplest form is, here from the origin all the points, all these 4 sides that you see are of same length, which we call as radius. Here in this case you are seeing 2 variants actually. You are seeing one radius along the x-axis, these two are same. This if I call this as, let's say, A, this is also A, this is B, this is also B. So we have, here we have only one radius. This is radius, this is radius, this is radius, this is radius. Here we have 2 different radius, 2 radii, whatever way you pronounce it, right? radii, radii,
Radii.
radii. Okay, is that how you pronounce it? Okay, sorry about my strong accent. So this is, you have two radii here and you have only one radius here. Okay, so the one that you see along the x-axis or the one which is bigger in length, that is called major radius, and the one that you see smaller in length, that is called minor radius. So here basically the main difference between ellipse and circle is, here you are dealing with two radiuses and here you have only one radius. So the two radius, one is called major radius, one is called minor radius. If I flip this ellipse like this, then this becomes my major radius, this becomes my minor radius. So my radius along the x-axis, let's say we give it a name A, and the radius along the y-axis we'll give it name B. So this is A, this is B. Up to this much, nothing confusing, right? Akshaya, Samriddhi, Dev, Tanvi, everybody, okay? Alright, so that's the primary difference. Now let's look at the equation that we are aware of, the circle equation, and then we'll try comparing that with the equation of a ellipse. So here you all know that the simplest form of a circle equation is x squared plus y squared equal to r squared, where x and y are the coordinates of x and y coordinates of any point of the circle, and then r is the radius. Yeah. If I write it a little differently, I can also say x squared by r squared plus y squared by r squared equal to 1. Is that okay? I can use the same form to describe it, or write the standard form of a circle equation as x by, along the x-axis what is my radius? A. X squared by a squared plus what is, along the y-axis what is my radius? That is b. So y squared by b squared equal to 1. So that becomes our equation of a ellipse. So if you look at ellipse or circle, you can imagine that if you squeeze it in a symmetric way, you'll end up getting a circle. Or if you squeeze the circle from top and bottom, you'll get an ellipse. So that is how you can relate them also in a layman's term. Is that okay so far? Alright. So the ellipse has, like in circle we know that, okay, any and every point from the center to the perimeter is same distance, that is called radius. With ellipse there is one interesting concept that says, if you take any point on the circle, or let's say you take 2 points along the horizontal or the major axis, okay? This is your major axis, this is your minor axis, okay? If you take 2 points along the major axis, and we'll call that foci or focal points or two focus, okay? The uniqueness of these 2 points is such that if you pick any point on along the boundary of the ellipse, this distance plus this distance will be equal to, let's say this is distance 1, this is distance 2. So d1 plus d2 will be equal to 2a. The magic about this property is, if I pick another point also, any other point, join this point and join this point. If this is my new d1 and this is my new d2, sum of the 2 points connecting the foci of the ellipse will be again equal to 2a. 2a is 2 times the major radius. Is this a concept that you had heard before, or is this something that you are hearing for the first time? Achaya, Tanvi, Samriddhi, Praneeth, Dev, anybody? Had you heard about this foci or the focal point before? You're aware of it? No. Okay, so.
Is that the same for the circle?
I'm sorry?
That's the same for the circle, right?
See, for the circle, I have not come across that concept. I mean, we can try deriving it, if that is valid or not. But this is something very specific to ellipse, which says that foci are two symmetric points along the major axis, such that, when I say two symmetric points, meaning if this is the first focus and this is the second focus point, the distance from the boundary here to here, if this is, let me not use the same term, let's say this is x, this will also be x. So the distance of the two focal points will be same from the end points of the major radius. Okay. So let's double click on that a little bit, and then we will. So let's forget about the circle for now, because I was using circle only to relate this, so that we can kind of see how relatable the equation of a ellipse is against what we know from a circle standpoint. So whatever we have learned so far, I'm just doing a recap. If you look at ellipse, let's say these are two axes, which is splitting this into 4 equal parts, and this is the origin, and here to here is the major radius A, which is along the x-axis, and the minor radius is B. What the focus or foci concept says is, foci is like two focus points along the major radius, such that if this is F1 and this is F2, and these two are equidistant from the end points of this major axis. I mean, same way it will be same distance from here also. Such that any point you pick up, any point, if you join this point with both the foci, the sum of this distance will be equal to 2 times the major radius. If you pick this point also, this distance plus this distance will also be equal to this. So I'm not trying to prove this here, but this is a definition or the description of a foci, which says that foci is like you say, radius is in a circle. Radius is something which describes that from the center to any point on the perimeter, the distance will remain the same. So that is a property of it. Same way for the ellipse, this is more like a property or the quality of this, which says that if along the major axis, these are 2 points which is equidistant from the end points, such that any point you pick up along the perimeter or the periphery of this one, sum of the two distances will be equal to 2 times the major axis, 2 times the major radius. So, I mean, just for the sake of simplicity, if you want to kind of wrap your head around this one, any point. So, I'm just picking up one point randomly, and then we will just try to be convinced about it. Okay, we can find out different methods to do it. So let's say this is my F1 and this is my second focal point F2, and distance from here to here, let's say C, by definition says these two distances will be the same, and from here to here it is A. Now let's say any point, right? So if I pick this point as one of the any point, distance from here to here will be what? This A, this distance plus, so let's say D1, which is distance from focal point to that point, is this distance here to here plus this distance. So this distance is nothing but A, and this distance is what? Plus A minus C. Plus A minus C. This is the distance from this point. Now from here, what is the distance? This is just C. So this D2 from second focal point to this point is only this distance, which is C. When you add these two, what do you get? A plus A minus C plus C. That gives you 2A. So I just picked up the extreme point. If I pick up another point, again we can prove that. I'm not going into that trap because you'll never be asked to find that out. But these two distances that you're talking about, you can always find out how much this will be. You can use trigonometry, you can use algebra concepts, you can use distance formula, whatever, and you'll still be able to prove it or be convinced about this fact. Does it make sense so far? Akshaya, Samriddhi, Tanvi, Vishal, Dev, Arush, David. And you don't have to say yes if there is slightest of a doubt. Okay. So now if we collate all these things, so what are the things that we have just talked about? So we are talking about ellipse which has major radius A, minor radius as B, and major minor can change. If I flip this ellipse by 90 degree or rotate by 90 degree, the radius along the x-axis will become minor radius like this. This will become minor radius. This will become major radius. And what we have seen is if the center of the ellipse is at the origin of the coordinate plane, the formula for the ellipse is x squared by a squared plus y squared by b squared equal to 1. Now, what if I move this ellipse? If my ellipse is not here, let's say I move the ellipse by, if my origin is here, meaning I have x coordinate value, let's say this is A, not A, let's say this is H. So I move this ellipse here, okay? So along the x-axis, my x coordinate, let's say, is H, and y coordinate will be 0 because I am moving along the x-axis. Can you tell me what will change for the equation of the ellipse now? Yep.
Do you change x to h?
No. You just moved it. See, you can read it like this: x minus h squared by a squared plus y minus k squared by b squared equal to 1, where h and k are the x and y coordinates of the origin or the center of the ellipse. Since my ellipse's center was coinciding with the origin, both h and k were 0, 0. So that's how become x minus 0 squared, that is x squared by a squared plus y minus 0, that is y squared by b squared. Now here I have just shifted the ellipse from here to here by h points. So it became x minus h squared by a squared plus y minus k. Here my k is y is 0. So y squared by b squared equal to 1. Confusing. Relatable. So basically I talked about this equation first and then I talked about this equation. This is the standard form of the equation for ellipse. If the center of the ellipse, meaning the point where the major and minor axis of the ellipse are coinciding, that coincides with the origin of the coordinate plane. If I would have talked about this in the beginning and said, okay, this is the equation for the ellipse, which says h and k are the x and y coordinates of the center of the ellipse. So this is your standard form. For the equation of the ellipse, meaning if you, let's say this is your coordinate plane and your ellipse is here. So this point's coordinates are h comma k. So if you have to derive the equation for this one, like in the case of circle also we saw, right? X minus x square plus y minus k square equal to r square. This was the standard form of the circle equation, correct? Where h and k are the coordinates of the center. If the center of the circle and the origin are coinciding, meaning your h and k value becomes 0, this becomes a flat equation, x square plus y square equal to r square. Same way here also, if the center of the ellipse is coinciding with the origin of the coordinate plane, your h and k value will become 0 and this transforms into this equation. So this is a standard form, this is a derived form, when your origin and center are coinciding. Are you guys able to follow me so far, or I'm getting you guys more confused?
Yeah.
Confused, yeah? Or follow, yeah?
So is it kind of like transformations, like shifting to the right kind of?
Right. So right now, when we looked at this equation, the first situation, right? What was happening was, we assumed that the center of the ellipse is coinciding with the center of the coordinate plane, or the origin of the coordinate plane. But that will not be the case always, right? If my ellipse is here, or if my ellipse is here, if my ellipse is here, can I use the same formula, x square plus y square plus y square by b square equal to 1? Probably not. Because here, what is the difference between this ellipse and this ellipse? Where are we accounting that? So this standard form, x minus h square by a square plus y minus b square, y minus k square, sorry, by b square equal to 1. This is my standard form, and depending on where my center is, this would keep on changing. So then you'll be able to differentiate between this ellipse, this ellipse, this ellipse, and this ellipse. Let me give one more example which might help you guys to relate it a little bit more. And then obviously we'll do some problems, right? So then only it will make a little more sense to you, because just me talking about the concept is going to be very, very easy to forget. Let's think of a situation, okay? I'm writing this here, x minus h square by a square plus y minus k square by b square equal to 1. And I'm claiming that this is the equation, standard form of the equation for ellipse. Are you okay? I mean, now look at this ellipse, this ellipse, this ellipse, and this ellipse. All four are copy paste, okay? I've just copied and pasted. Meaning, see, for the ellipse, what is important? Like in case of a circle, what is important? Two things. Where the center is, how much is the radius. That's the only thing. In case of ellipse, same thing. Where is the center and what is the major axis, major radius and minor radius. What is the center? What is the major radius? What is the minor radius? Where is the center? What is the major radius? What is the minor radius? What is the center? Where is the center? What is the major radius? What is the minor radius? If you assume that all these four ellipses are copy of each other, meaning the dimensions are same, sizes are same, major and minor radius lengths are same, how do you differentiate between this guy, this guy, this guy, and this guy? Only difference is if the properties are matching, meaning the major and minor radiuses length are same, only thing that is differentiating among them all is where they are located, meaning where the center is. And that gets determined by this. All the four you are seeing here, let's say, let me assume that I am putting in a very symmetric way, meaning this length is same as this length is same as this length, okay, if I put it that way. Then also, what's happening is here the coordinates are h, comma k, h, comma k. In this case, the coordinates of the center would be minus h, length is same but negative side, but same positive k. In this case, my x is positive, so my x coordinate of the center would be h is fine, but k will be minus k. In this case, both are on the negative side, so my x is also x coordinate is also minus h, and y coordinate is also minus k. Yeah. So the coordinates of the center, even if every other properties are matching, only the coordinates of the center is determining where the ellipse is on the coordinate plane, and this will help you map it to how do you kind of derive the location of the ellipse. Because now when we are in the coordinate plane, right, it's not only about the magnitude, it's not only about the length of this thing, it's also important to know where the center is. Because otherwise, if you're not caring about it, then what is the difference between these 3, 4 ellipses, 5 ellipses, 6 ellipses? Even if they are just copy pasted over and over again, how do you differentiate between them? So the location, magnitude and the location. Here location means coordinates. Yeah? Am I making sense, Tanvi? Akshay? Samriddhi? Dev? Praneeth is a very defensive guy. As soon as he saw me asking questions, he first raised his thumbs up. Okay. Alright, no, I'm just kidding. So this is just the concept. Meaning, how do you visualize the equation of ellipse? What are different forms? And then, what is a foci? What is that we need to know about the minor and major radius? How do we relate that? And now we'll look at some real problem that you guys will come across as part of this topic, and that will help us make sure that whatever we have learned or talked about, we are able to apply that for solving some problems. Any questions, any doubt if you guys have before I jump onto problems, please feel free to let me know. Everybody okay? All geared up to see some problems? Okay, let's look at it. Okay, so here is one question that I have. And I will try not to solve this. I would rather want you guys to tell me what is your understanding based on whatever we have discussed. 1, 2, 3, and this is 4. So what I'm trying to say is, on the y-axis, the major axis is crossing this point where y is equal to 3. And then here, 1, 2, 3. Okay, I have given you guys enough clue. Here it is. This point is 2.5 and this point is 3.5. Okay. Now you guys can see this drawing, right? Again, I'm just helping you guys visualize this. This is my center of the ellipse, which is at y equal to 3, and here the end point is at x equal to 3. And when you look at the minor radius side of it, this center is at 3 and this is 3.5, this is 2.5. Okay, I did not do a great job with drawing, so I will say this is 2. Hope that makes it more relatable for you guys.
So like the edges or the vertical edges are like 2.5 and 3.5.
These two? Yeah, 2.5, 3.5.
Okay.
Okay. Now, I have just drawn it, okay? Now, what happened to my phone? This guy died. Oh. Are you on this one? On the WhatsApp group?
Yeah.
My phone's battery died. Can I borrow your phone to read the question?
Yeah.
Sorry about that. Oops, not this one. WhatsApp group, WhatsApp.
Yeah, that's WhatsApp.
No, I have not loaded it. Can you open it for me? I'll go to the pre-calculus group where I had put the questions.
It's not showing anything. Yeah, there's like nothing there. See?
Okay. Then are you on? Okay. Let me do one thing. Guys, sorry about this. I'll just quickly run and get my charger. Just a second. Oops. I'm messing up. Sorry everybody for this last minute mess. Okay, while I'm starting my phone, can you guys tell me what will be the coordinate of the center?
3, 0.
Okay. Dave,
It would be 3-0, so we'll have to do
3-0.
Yeah.
How about Pranit?
3-0.
3-0.
Oh wait, no, it's 0-3.
That's what I was waiting for.
Oh,
Coordinates.
they all copied me.
0-3, sorry.
Yeah. So coordinates always written x comma y. My x coordinate here is 0. Y coordinate is 3. So this is the center. Okay. Now, can you guys convert in this based on the ellipse formula we know? While my phone is still starting, it might take a. Okay, it's done. Okay, let me read the questions and extremely sorry guys for wasting your 5 minutes. I was not keeping an eye on how much charge my phone has.
How do you come to the movie?
6:30, 6:15 is too late.
When?
Okay.
6:30, 6:15 is fine.
What is the center? You guys told me. What is the minor radius or semi-minor axis? So minor radius is called semi-minor axis. Major radius is also called semi-major axis. So don't get confused between these terms. They are all the same. So what is the minor radius in this problem?
0.5.
Tanvi, Samriddhi, Akshaya. How much you guys think is the minor axis or minor radius? Pranit, I will come to you later. Wait. I want to know if I was able to explain this to Samriddhi, Akshaya, and Tanvi also. Yeah, Tanvi.
Is it 0.5?
Okay. Akshaya.
Is it like the y-axis? Like, or
Right.
there's like a specific point.
Yeah, so it's saying, the question is, how much is the minor radius?
Yeah, 0.5.
So minor, see, whenever you see an ellipse, right? This is your major radius. This is your minor radius. Okay? Whichever is thinner, okay? If I flip this by, or rotate this by 90 degree, then this becomes your major radius. Yeah?
Yeah.
So basically, I will not relate minor or major radius with x or y axis. I'll just go by what is the orientation of the ellipse, and based on that I will determine whether axis is my minor radius, or my minor radius is along the x-axis or is along the y-axis, depending on the orientation of the ellipse. Yeah. Samriddhi, is that okay with you, beta?
Oh yeah.
Okay. Yes, Dave.
Wait, so does the minor and major word change depending on the shape?
Depending on the shape or the orientation, yes. In this case, my major radius is this one. In this case, my major radius is this one. So I would not say that whatever is along the x-axis is my major radius. No, because it depends on the orientation.
So is the one that is the orientation it's stretched in the most major?
Yeah, wherever it is stretched the max is the major one. I mean, just go by English, right? This is a bigger radius. This is a smaller radius. Bigger is major, smaller is minor. This is your major. This is your minor. Yeah, Pranit, what was your answer?
0.5.
0.5. Okay, so everybody gave 0.5. So the radius is half of this whole width, and this is symmetric. Okay, we are not talking about a shape which is like this. Okay, we are talking about shape which is very symmetric along these axes. Okay. Okay, so that was second part of the question. Let's see what else it's asking for. Okay, this was the first one. Now there's another. Okay, let's. I'm not going to go into other axis. Diagram and say okay, find out the center or the minor major radius. Okay. Now let's do some cool stuff with bit of calculation. So this one is, you are given the equation as, the equation of an ellipse is given as below: x minus 4 squared by 4 plus y minus 5 squared by 36 equal to 1. What is the center? What is its center, meaning x and y coordinates of the center, and what is the major radius, and what is the minor radius? Who can tell me that? You have an equation of the ellipse given. You have to find out the coordinates of the center and minor and major radius. Pranit is ready, but I will wait for 2 more hands to be raised before I let Pranit tell the answer, because what happens is, if Pranit tells the answer, everybody will get biased.
I have a question.
Yes?
And the B value, is it 3.6 or 36?
36.
Okay.
Okay. Dev and Pranit are ready. I would wait for 1 more person to raise the hand. Be it Vishal, be it Tanvi, be it Akshaya, be it Samriddhi. So everybody got the question, right? Yeah. You can write it down for me. Huh? Yeah, you can write it down for me, okay? Okay, yeah. A6 or B6. A6 or B6.
No, A is equal to
What is the major radius? What is the minor radius? Okay, okay, okay. And what is the coordinates of the center?
Oh wait, just that.
and its water center is this one right here.
Okay.
But uncle,
Okay.
if B is like greater than A, that means the ellipse is vertical, right?
Yeah.
Okay.
Yes, Pranit, tell me what your answer is. What is the coordinates of the center?
Coordinates of the center, I have 4, 5,
Okay.
and then my major radius is 36.
Major radius is?
36.
Are you sure?
Wait, not 36, 6.
How about minor radius?
Minor radius would be 2.
How about you, Dev?
I was gonna say the same.
Same thing. So, see, there's nothing difficult about this one, okay? It's just about relating that with what we know. This is the standard form of a ellipse equation, okay? Here it says x minus h squared by a squared plus y minus k squared by b squared. Here this is a squared and this is b squared. This is h, this is k, where h and k are the coordinates of the center. X minus h, so this is minus, so means h value is already positive, so 4. Y minus k, this is 4 y minus 5, so basically k value is also positive here. So 4 comma 5 becomes my center, and this is a square. So my radius along the x-axis is 2 square. 2 square is 4. Radius along the y-axis, because y divided by is b square 36, so that is b is 6. So this is my radius along the x-axis, this is my radius along the y-axis. Now, if the question says what is the major radius, this is the major radius. This is bigger. So you don't have, again, I might sound redundant by saying that don't go by the denominator of x side of things as your major radius or minor radius. Go by the value. Whichever is smaller, that is minor radius. Whichever is bigger is your major radius. No bias with x or y, because my ellipse can always flip. Yeah. Samriddhi, Tanvi, Akshaya, Vishal, everybody okay? Now it's a bit of a twister. Okay. I'm just trying to bother you guys a little bit. X plus 2.5 square plus y minus 3 square okay, this is the equation. 4 times x plus 2.5 square divided by 25 plus 2 times y minus 3 square divided by 18 equal to 36. Find out the coordinates of the center and the minor and major radius. Okay, did everybody get the question? Akshay, Vishal, Dave, everybody? Yeah. So I'm just reading it for you guys.
Does it say 2? Like in the second part, does it say 2?
Yeah.
Like,
See, that is one thing that you guys have been dealing with me, right? My writing and my drawing skills are a question mark.
Is 4 multiplying to x plus 2.5 squared, or is it multiplying to the whole like thing? Okay.
4 times x plus 2.5 square divided by 25 plus 2 times y minus 3 square divided by 18 equal to 36. I want you guys to find out the coordinates of the center and major and minor radiuses. Yes, Arush.
Okay, there's the center XY. This one's minor, this one's major.
Okay.
Wait. No.
I know it's a little bit of a twister, but not that big a problem. If you get your hands dirty, you'll be able to find a very clean solution. See what I mean by hands being dirty.
So brackets are-
And you guys have 1 more minute or 2 more minutes. What happened? Everybody's quiet. Akshay, how does it look, beta? Difficult? Easy?
Well, like, I don't know if I should, like, do something with 36 first or distribute the force. So,
Okay. So, okay, just in the interest of time, I'll give it a try. Okay. I cooked up this problem, right? I mean, you may or may not find this problem in, but anyways, here, what is the kind of equation we are used to? X minus h squared by a squared plus y minus k squared by b squared equal to 1. This is the most standard form that we are used to. Here it is looking something different. Then it boils down to how do you simplify it first?
Turn 36 into 1. Do you divide by 36 or do you subtract by 35?
Divide. If you subtract, what will happen here?
I don't know.
And that will become more complicated actually. Yeah.
2 and 18 cancel to become 1 and 9.
So see that is what I'm going to do. So what I'm telling you guys is this is the most standard form that we are used to. So I have to convert, or we have to convert this whole thing into this form so that we can relate. Because once we get into this form, then we'll say, okay, this is my center, and this is my one radius, this is my other radius. Whichever is bigger or smaller, we'll call it major or minor radius. Yep. Is everybody with me? Dave, Vishal, Tanvi, Praneet, everybody? So first thing is, we are not used to seeing a 36 here. We'll give or here we have a 2 and a 19 here. Let's see wherever we can simplify. 4x plus 2.5 squared. Let's assume that we know the center already because this is the center part, right? So my center is x minus h, minus of minus will give me plus. So this is my h and y minus k. This is the most potential coordinates of the center that we can find by the equation itself. Now 2 by 18 is nothing but y minus 3 over 9, correct? 2 times 9 is 18.
You forgot to square it.
Yeah. And then I have a 36 here. Other thing I can do is, can I not say this as x plus 2.5 square divided by 25 over 4, which is nothing but 5 square, 5 by 2 square. Yeah. So see, we are getting there. So this whole thing became x plus something squared by a square, y minus something squared by b square. This is nothing but y minus 3 squared over 3 squared equal to 36. Now we don't need this 36. What we can do in the next step is, we'll say, okay, fine, this is x plus 2.5 squared by 5 over 2 squared, x minus this square by a square, plus y minus 3 square by 3 square equal to 1. What we did was, we removed 36 from here, meaning we divide everything by 36. So we divide by everything by 36. Now this part remains the same. Look at the denominators. 5 by 2 into 6 square, 3 into 6 square. This one became this one became this. 5 over 2 into 6 gives you nothing but 15. 3 2 is 6, so 5 into 3, 15 square, and this is 3 into 6, 18 square. So basically, whatever I am doing here, this is more of an attempt to simplify. Why? Because we know that my standard form of an ellipse is x minus h squared by a square plus y minus b squared by y minus k squared by b squared equal to 1. If I see this, I will knock it off. Main divide by 36, everything gets divided by 36, so 36 becomes the denominator in both the cases. And then you simplify this, that's it. So it was all about simplification. As long as we are crystal clear about the formula that applies for an ellipse, we just have to relate it with that. And for relating with that, we have to simplify it so that it looks more convincing. Otherwise, there was a potential of we getting lost in the whole calculation. Yeah? I think that's where you guys were scratching your head with as well, correct? Akshaya, Samriddhi, Tanvi, Dev, everybody? No, I'm not saying that you guys were scratching your head. I'm saying, this is what you were trying to solve, right? So, net, a problem that comes to you in the exam, it will not be straightforward. It will not say that, okay. It will not always say that you have an equation for the ellipse, find out the center and the major and minor radius of that. X minus 8 squared by 64 plus y minus 3 squared by 81 equal to 1. You will not always get a question like this. There will be a little bit of twisting that will be done, like how I cooked it up for you guys. But main thing that you have to keep in mind is I am not going to shake even a little bit when it comes to knowing the standard formula for this. My formula is going to remain as stubborn as my teacher, and it will remain like this. Now, how do I relate it with this form is where your calculation will go. Yep. Now, Akshaya and Samriddhi, who are less aware of my jokes, will think that, oh, we never knew that my teacher is so stubborn. But I was saying that it's about being firm about your your ability to relate to the concept part of it. That's where I was saying that we need to be very, very clear, and we can be stubborn also if we need to. Okay? But is that okay? Is everybody clear so far? Or hungry for dinner? Both? Okay. I will just flash one last problem so that you guys can just look at it, okay? And we have just a couple of minutes, not even a couple of minutes, we have just one more minute before officially the class gets over. But let's and this point is 6. 1, 2, 3, 4, 5, 6. And this point is 4. This point is 4. 1, 2, 3, 4. So this is the equation, this is the picture that is given to you, where you can see that the major radius is meeting y-axis at 0.6. Where y-axis at y value of 6, and this center is coinciding with 4 of x. Can you guys quickly write down the equation for the ellipse, for this picture? I have given you the picture, you have to write the script for me, meaning write the equation for this. It should not take more than 30 seconds.
Can you also post it like on the WhatsApp?
Yeah, this is already on the WhatsApp better.
Oh.
So these questions were there on the WhatsApp group actually. So you can try it after the class also. Yeah.
I got it.
Yeah. What is that?
X minus 4 squared
Mm-hmm.
over 16
Okay.
plus y minus 6 squared over 36
Then
equals 1.
okay. Yeah, brilliant.
I got nearly the same thing except y minus 6. I got y plus 6.
Okay.
That was the only difference.
But why would that be the case? Okay, I'll come to you. Yeah.
Wait. So wouldn't the minor radius be 2 to 6 equals 2? So we're at 52 squared instead of 36.
Spot on.
6 squared.
Yeah, good catch. So here, see, for the ellipse, again, same thing. Like in circle, you need to know the origin and you need to know the radius. In this case, you have to find out two radius and you have to find out the center. So the center is what? Look at the coordinates of the center. X coordinate is 4, y coordinate is 6. So we got h equal to 4, k equal to 6. Now, what is the major radius? Major radius is 4. Here, major radius is along the x-axis, so I am calling it A. What is my minor radius? This is this length, 4 to 6. So my B is nothing but 2. Now if you plug that into this equation, x minus h squared over a squared plus y minus k squared over b squared equal to 1. So you are going to plug in a equal to 4, b equal to 2, h equal to 4, k equal to 6. Done. That's why I was saying that if I was able to explain this concept okay to you guys, it should be a real big thing. And again, when you practice few problems, you will be able to relate that and do it with much more comfort and ease. Yeah. With that being said, any questions? I mean, did I make sense, everybody? Praneeth, were you able to see what I did versus what you were doing was different? Akshaya, Tanvi, Vishal, everybody comfortable? Okay, so then there is a reason for being more comfortable. Take some rest, have a good dinner, and try doing the unit test on Khan Academy for this one, for Conic section. At least, just to see how much easy it is for you guys to solve it. If there are problems, obviously we are not done with this whole thing yet. We'll do some more problems in the next class where we'll talk about any of the remaining part of ellipse, and then we'll go to, we have not derived the formula for the foci, the focal length. We'll look at that, and then we'll do maybe one or two problems, then we'll go to hyperbola and other concepts for Conic sections in the next class. Alright, take care, see you guys coming Saturday. Alright?
Bye.
Yeah, bye bye. Bye bye, good night.